Hello dear students, welcome you to the video tutorial on the cryptography. So in today's video we are going to discuss about the internet key exchange, okay, which is called as IKE. So we know that in the security associations the three factors are playing very important role. One is confidentiality, and next is authentication, and third one is key management. So we have seen this confidentiality and authentication in ESP protocol as well as in the AH protocol, where we have more concentrated on ESP protocol because ESP protocol provides both the confidentiality service as well as the authentication service. In the key management, the very important terms we need to understand is how this key exchange happens in the internet. This is called as internet key exchange, IKE. So this is the topic of the key management. So this IKE, it is having two phases: IKE phase 1, IKE phase 2. So before we can protect any IP packets, we need two IP security entity that builds IP security tunnel. Okay, so before we go for the security in the IP packet, before we can protect it, actually we need two IP security entities that builds the IP security tunnel. To establish the IP security tunnel, we use the protocol called as IPsec. So we have to protect our IP packet. To protect our IP packet, we have to build IP security tunnel. IP security tunnel has to be built up. So how this IP security tunnel will build? IP security tunnel will be built by using the protocols of IKE, Internet Key Exchange protocols. Okay, so to build this IP security tunnel, we have to use the protocol that is called as IKE protocol, Internet Key Exchange protocol. So there are two phases in the Internet Key Exchange protocol. So first phase, IKE phase 1, it is called as IKE V1 or phase 1 version 1. Second one is IKE phase 2 P2. Okay, so in the phase 1 will authenticate the users. Mutual authentication happens between the sender and receiver, and the session keys will be exchanged between the sender and receiver. So mutual authentication means sender should know who is the receiver and receiver should know who is the authentication sender. Okay, other users cannot send the data, and while doing this they also exchange the session keys. Already we have studied these things in the previous modules. In the IKV phase 2, we use the result of phase 1, that is mutual authentication and session key establishment, to create a multiple associations between the same entities. Between the same entities means between the same sender and receiver, we will create the multiple association. As we can see in the figure, in the phase 1, we have developed only one tunnel, one IPsec tunnel between the sender and receiver. So it is the receiver and this is the sender, where in the first phase mutual authentication between sender and receiver will take place, as well as the session key will be exchanged between the sender and receiver. So in the phase 2, it will uses the results of phase 1, and there it will create a multiple association between the same sender and receiver, same entities, you can see here. So multiple security associations are generated here in the phase 2. So IKE phase 1, let us see what is there in the IKE phase 1. The two peers negotiate about the encryption. Two peers are nothing but the sender and receiver. So these are the two peers. So they negotiate about the encryption. That means they will share the information about the encryption algorithm, which type of encryption algorithm they are using, which type of authentication algorithm are using, hashing, which type of hash algorithm they are using, and other protocols that they want to use, and some other parameters are required. So in the first phase itself, they will negotiate. They will negotiate means they will exchange all this information. what encryption algorithm they are using, what authentication algorithm, what type of hashing they are using, and other protocols and other parameters which are required for the secure communication. All this will be negotiated between the two peers. In this phase, an ISA-KMP, this is a protocol which is present in IKE. So IKE, actually we have two modes here for the generation or for the exchange of key. One is manual mode, another one is automatic mode. So in the automatic mode, we'll study what is manual mode and what is automatic mode in the later. So in the automatic mode, we have two algorithms that we will use to exchange the keys. One is ISA-KMP. Another one we will use is Oakley key. Oakley key. Okay, so these are the two automatic key exchange algorithm that we are using. So here in the first phase, we are going to use about ISA-KMP. ISA-KMP is nothing but Internet Security Association and Key Management Protocol. So this protocol is used to establish the session between the two parties or two peers. This is also called as ISA-KMP tunnel or IKE Phase 1 tunnel, because the tunnel is generated between the two peers, sender and receiver, where they can negotiate about the encryption, the authentication, the hashing and other protocols, and whatever the other parameters they are required for secure communication between the two peers. All these things will be exchanged here. They will make a tunnel here. So this tunnel, we'll call it as IKE Phase 1 tunnel, or we can also call it as ISA-KMP tunnel. ISA-KMP is nothing but Internet Security Association, Key Management and Key Management Protocol. Okay, so the collection of parameters. So in the negotiation phase, what they have done, they have collected all the parameters that they want to develop or they want to communicate the IP packet securely, that is SA, Security Association. All the parameters of the security associations between the sender and receivers will be negotiated. So you can see here, as I told, so there are two routers you can see in the example. So IKE Phase 1 tunnel is established for the secure communication between the two parties or two peers. Okay, so in the negotiation, it will exchange all the type of encryption algorithm that it is using, authentication algorithm, and also it tells you about the hashing, which hashing function they are using, what are the other protocols they are using, other parameters. All these things will be exchanged or negotiated between the two peers. And for the exchange of these values, we have created a tunnel here in the phase 1, that is called as IKE Phase 1 tunnel, or it is also called as ISA-KMP tunnel. ISA-KMP tunnel. What is the purpose of this ISA-KMP phase? IKE Phase 1 is, it is only used for the traffic management, managing the traffic between the two parties. This tunnel is used as a secure method to establish the second tunnel called as IKE Phase 2 tunnel. So this is phase 1. As we know that phase 2 uses the result of phase 1. So what is the result of phase 1? We have developed the IKE Phase 1 tunnel, and this will be used by IKE Phase 2 tunnel. IKE Phase 2 tunnel. Okay, or IKE Phase 2 tunnel is also called as IPsec tunnel. It is also called as IPsec tunnel. Okay, right. So let us see what is there in the step 1 in the phase 1. What are the steps in the IKE Phase 1 step? The main purpose of IKE Phase 1 is to establish the secure tunnel that we can use for IKE Phase 2. So the main purpose of IKE Phase 1 tunnel, so to establish the secure tunnel, because we are using the same tunnel in IKE 2 for the security purpose. So we can break down the phase 1 into 3 simple steps. So first one, negotiation. As I told, there is a negotiation happens between two peers regarding the authentication algorithm, regarding the encryption algorithm, regarding the hashing, regarding the lifetime of the security association. So all these things will be negotiated here. You can see here hashing, which hashing algorithm we have to use, that two parties will communicate with each other, and they will come to the conclusion that okay, we will use this MD5 or SHA hashing algorithm. Also, there will be negotiation for the authentication algorithm, which authentication algorithm we need to use for the security communication, which key exchange algorithm we need to use, what is the lifetime of our communication, and what encryption algorithm we need to use. So all these things will be negotiated between two peers. This is the phase 1 or step 1 in the phase 1. Step 2, Diffie-Hellman key exchange algorithms will be used to exchange the keys, secret keys, to exchange the key between the sender as well as the receiver. Both pair will have the shared keys. Okay. If the generated value of both keys are same, then we will call it as keys are exchanged. Already we know Diffie-Hellman exchange algorithm. This is the step 2. In the step 3, authentication will take place, that two peers will authenticate each other by using authentication method that they are agreed upon in the negotiation. So in the negotiation step, they have agreed upon the authentication. You can see here. So they can use any authentication algorithm so that they can authenticate who is the sender and who is the receiver, whether we have sent it to correct destination or not, or whether the message received is by correct sender or not. That authentication we need to check here. Okay, so the end result of IKE phase 1 tunnel, that is ISA-KMP tunnel, which is bidirectional. Bidirectional means both sender and receiver will communicate in two ways. So what are the modes of the phase 1, IKE phase 1? So IKE phase 1 have two different modes. One is main mode, second one is aggressive mode. In the main mode, 6 messages will be exchanged between the two peers. In the aggressive mode, we will exchange 3 messages. So remember that ISC-KMP, it will not detect you, or it will not dictate you the particular protocol that you have to use. It only acts on the messages that you can exchange between the sender and receiver, or you can exchange between the two peers. So as I told, main mode, 6 messages will be exchanged between the two parties, and in the aggressive mode, 3 messages will be exchanged between two parties. So main mode is having more security than aggressive. Okay, so main mode is considered as more secure than compared to aggressive mode, because 6 messages will be exchanged between the two parties. So this is the main mode. You can see here 6 messages. So this two messages, first two messages. So that is crypto suits I support, crypto suits I choose. This is for the negotiation. So it is called as cookies. Cookies will be established between the two parties. So in the third and fourth is for the Diffie-Hellman key exchange algorithm. This is negotiation. So we know 3 steps here. So 3 steps in the phase 1. So negotiation, Diffie-Hellman key exchange, then authentication. So this is first 2 messages are step 1. Second, this message 3 and message 4 is for Diffie-Hellman key exchange algorithm, and the last 5 and 6 are for authentication. Okay, so you can see here. So key has been exchanged here. Half of the keys has been exchanged here, and here we are generating a message digest. It is called as message digest. So message digest will be generated in message 5 and message 6. This is called as message digest, MD. Okay, that has been generated in the 5 and 6. Okay, so totally 6 messages has been exchanged in the main mode. So another mode is the aggressive mode, where I told that the 6 messages will be combined and made into 3 messages. The message 1 is the combination of message 1 and message 3 from the previous main mode. Message 1 plus message 3 is combined here to make message 1. So you can see here, Diffie-Hellman 1 key is exchanged here, as well as the negotiation takes place here. Cookies can be established. So this message 2 is the combination of message 2 plus message 4 plus message 6 in the previous step. So this message 2, message 4 and message 6 of the previous step is combined together, and we have formed this. So you can see here, half of the key exchange here and another half of the key exchange here, Diffie-Hellman key. And then we have the fourth one, that is negotiation is also there. You can see crypto choice, and we have authentication here. And this message 3 is just message 5 of the previous main mode. Message 5 of the previous mode. So like this, this all 6 messages are combined together and made like 3 messages here in the aggressive mode. So IKE authentication method, the original public key encryption. These are the authentication method. So original public key encryption is one of the authentication method. Revised public key encryption is another method. Public key signature, that is nothing but digital signature. This is another method for authentication. Digital signature. And pre-shared secret key. This is another authentication method. So in the original public key encryption, what we'll do? Separately encrypt each field with other side's public key. Okay, so other side means the receiver side. Consider he is the sender. We will encrypt the sender message by using the public key of the receiver. Okay, this is called as original public key encryption. Revised public key encryption means encrypt the session key with the public key. So here we will use the session key of the other party for the encryption purpose. Then digital signature you know already. So how to generate digital signature? We have to encrypt it by using private key, and the receiver will decrypt it by using public key. So this is how the public key signature is there. And then pre-shared secret key. So this is the secret key exchange algorithm, or this is symmetric authentication, symmetric key authentication. So we have secret key that is shared between sender and receiver. So 4 methods will act on 2 modes. What are the 2 modes? Main mode, aggressive. Main mode, aggressive mode. So 2 modes, so 4 methods. These are the 4 methods. So 2 modes, total 8 variants are there in the phase 1. So this is all about IKE phase 1. Now let us see in the phase 2. So as I told, phase 2 uses the result of phase 1. The result of phase 1. You can see here, this is phase 1 tunnel which is established in the phase 1, IKE phase 1 tunnel. For that, we will add phase 2 tunnel. Phase 2 tunnel. Once IKE phase 2 is completed, we have IKE phase 2 tunnel. This whole thing is IKE phase 2 tunnel, which consists of IKE phase 1 tunnel that we can use to protect our user data. So this whole thing we can use to protect our data, users data. Right. So this is how the steps happens in the phase 2. So phase 1, because it takes the output from the phase 1, in the first step, phase 1, security association is established here. So 3 steps in the phase 1. Remember these 3 points very carefully. Next, from Alice to Bob, from sender. This Alice is sender, Bob is a receiver. So what all the information is there exchange, you can see here X, Y, CP, traffic, SP, IA, nodes A. Then this Diffie element key exchange algorithm. So what is X, Y? X is nothing but pair of cookies generated by phase 1. So as I told, cookies will be generated in the negotiation step. Okay, so X is nothing but cookies generated in the phase 1. So here this X cookie is generated. Y is nothing but the 32-bit number which distinguishes the phase 2 session. So Y is the 32-bit number to distinguish different phase 2 session. CP is nothing but the crypto proposal. You can see here CP, crypto proposal. CPA is nothing but crypto proposal accepted. Okay, so crypto proposal accepted. Right. So SPI, security parameter index of Alice, nodes of Alice, then key exchanged. Then key exchanged. Okay, so here for the key exchange, we will use Diffie-Hellman key exchange algorithm. So X and Y are in clear rest of the phase 2 messages are encrypted and integrity is protected here. So this acknowledgement is passed from Alice to Bob after receiving all the information. So you can see here Alice will send first all information to Bob. Bob will also send the information to Alice, and later Alice will acknowledge to the Bob by using cookies as well as the distinguish this 32-bit number to distinguish the phase 2 session. Okay, so this is about the phase 2. So as I told that internet key exchange, it acts in a two mode, or if we want to generate a key, we have two method to generate the key. One is manual method, one is automatic method. So in a manual method, a system administrator manually configures the system with its own keys and with the keys of other communicating system. So here the system administrator will manually generate his own keys. Okay, and that keys has been shared between two peers. But in the automatic key exchange method, the system enables on-demand creation of keys for SA, Security Association. So it is on-demand. No users, no administrators will come into picture here. And facilitates the use of keys in a large distributed system with an evolving configuration. The default protocols, as I told, in the automated system is ISA KMP, which we have solved just now, and Oakley key distribution. So ISA KMP, that is Internet Security Association and Key Message Key Management Protocol. Already we have seen this ISA KMP here. So you can see all ISA KMP. I already discussed about ISA KMP is used in automated mode. So the same thing is here. And one more thing is Oakley key exchange method. So automatic key management protocol. So these are the two protocols. Oakley is one of the protocol, and then ISA KMP. It is another protocol. Already we have studied about ISA KMP. Let us just look at what is there in the Oakley. So Oakley key distribution protocol, it is based on the Diffie-Hellman key exchange algorithm. It provides the added security to Diffie-Hellman key exchange algorithm. So if we use Oakley's protocol, it adds some more security to Diffie-Hellman key exchange algorithm. Already some security is there with Diffie-Hellman key exchange algorithm, but if we use Oakley's key distribution protocol, it will add some more security to the Diffie-Hellman key exchange algorithm. So it is generic in nature. So this Oakley's protocol, it is very generic. Whereas ISA KMP, already I told, it provides the framework for internet key management. It provides the specific protocol for support for the negotiation of security attribute. Okay, we have seen this negotiation step and key exchange step, so and third authentication step in the previous discussion. So key determination protocol, as I told, this key determination protocol, it is nothing but it is the improved version of DH protocol, improved version of DH algorithm, Diffie-Hellman key exchange algorithm. Okay, where the advantages are retained while encountering the weaknesses. So the advantage of key exchange, Diffie-Hellman key exchange algorithm is already there, provided plus some weakness we are converted into as a useful advantage here. Some weaknesses we have taken from the Diffie-Hellman key exchange algorithm, that also we have converted into the advantage. So this is the scenario that you all know how the key exchange takes place. So I don't want to explain much about this. Lastly, it will calculate the K value. If both K values are same, then it is called as key has been exchanged. What is the attractive feature of Diffie-Hellman algorithm here? Secret keys are created only when needed. So only when key exchange is needed, then only secret keys are created. The exchange requires no pre-existing infrastructure other than the agreement on global parameters. So you should not have any pre-existing infrastructure for the exchange purpose. Okay. So what is the weakness of Diffie-Hellman? Does not provide information about the identity of the parties. It is subjected to man-in-middle attack. So as we already know, man-in-middle attack, he can attack the key in between. Okay. And then computationally intensive and hence it is vulnerable to clogging attack. It is computationally very intensive because every time we need to generate the generic value and then we need to do the calculation. Hence it is vulnerable for clogging attack. in which the opponent requests high number of keys. So features of IKE key determination. So first one, it employs the cookies to thwart the clogging attack. So what it makes use of cookies to overcome the clogging attack. Okay. So what is the second feature? Enables two parties to negotiate a group. So two parties can make a group, and by making the group they can securely negotiate the parameters, whatever parameters they can use for the security association, like encryption algorithm, exchange, authentication algorithm, hashing algorithm. All these things they can make a group of the people and they can negotiate between that. Uses nodes to ensure against a reply attack. Okay, so you know what is reply attack. Already I have explained about reply attack, and what is nodes also I have explained in the class. So this is the third feature where it uses nodes to ensure against the reply attack. Enables the exchange of Diffie-Hellman public key values. So this IKE key determination, it also enables the Diffie-Hellman key exchange algorithm to exchange the public keys. It authenticates the Diffie-Hellman exchange to thwart or to avoid the man-in-middle attack. Okay, so to reduce or to avoid the man-in-middle attack, this IKE key determination, it also authenticates Diffie-Hellman key algorithm, Diffie-Hellman key exchange algorithm. So this is a clogging attack. You can see in the picture. So user A, user B, all they want to communicate with the server, but here there is a malicious user. Here he want to generate more number of keys. So while generating more number of keys, this server becomes clogged. Clogged is nothing but the server is confused because it is generating so many keys and so many keys are shared between the users. So this is called as clogging attack. So how to avoid clogging attack? We can avoid the clogging attack by generating cookies. Okay, this is one of the examples. So this is IKE version 2. As I told, the exchange of messages between the sender and receiver. We know that first initial exchange takes place. So what is there in the initial exchange? So in the initial exchange, we will exchange all these values, HDR between initiator and responder, HDR security association. We will exchange keys also. KE is nothing but key exchange. Diffie-Hellman key we can use. We also use nodes for the explanation. This is certificate we will exchange. So this is the initial exchange. This is the first step. And in the second step, we will create a child for security exchange. Okay, so we will create a child for security exchange. So you can see here all these things are explained here. What are this HDR, SK, NSA, all these things are there here. You can see this. And this is the third step here. So after initial exchange and after the security establishment, security association is established, then we can exchange the information. So information contains this notification, deletion of the notification, configuration. Okay, then this is IKE header. This SK is nothing but you can see here SK is the MAC and encryption. MAC, MAC, media access control, and then encryption. So these are the three steps in the IKV exchanges. So this is the IKE formats. You can see here. So it is total 32-bit format from. So we know that SPI. This is a responder of security parameter index. Next payload. This is major version. This is minor version. MJVAR is major version, which is of 4 bits. Minor version is also 4 bits. So major version is used for IKE. Major version is used in the IKE. Minor version is also used. So 4 bits are given to this. Exchange type. Okay, so which exchange algorithm we are using, that is there. It is of 8 bits and we are using flag bits. Flag 8 bits flag. Okay, then we are using message ID. That is used to control the retransmission of lost packet and matching of the request and response. For this purpose, we are using message ID. So message ID is nothing but it is a number which is given to the message. So if any message is lost in between, we can check this message ID and we can retransmit that lost packet to the request and response. Then this is the total length of message. Length is nothing but total length of a message. This is the IKE header. And this is the diagram for generic payload header. So generic payload header is also of 32 bits. So we already know about security parameter index. It is of the size 64 bits. Okay, so you can see here initiator security SPI, the value chosen by the initiator to identify the unique IKE security association. Okay, then this is responder SPI. It is also 64 bits. A value chosen by the responder to identify the unique security association. This is by the initiator and this is by the responder. This ESP initiator SPI will be the value which is chosen by the initiator, and here this responder SPI is the value chosen by the responder. You can see here responder and initiator. He will also use his own unique value, and he will also use his own unique value for the security association. So this is called as initiator SPI, and this unique value is called as responder's SPI. So what is the total size here? 64 bits. Here also it is 64 bits. Okay. Right. Next payload. It indicates the type of the first payload in the message. Payloads are discussed in the next subsection. We will know what is payload. Payload is nothing but data. Okay, the data which we have, because we are working in network layer. For network layer, the data is received from the transport layer. What transport layer consists of? Already we have seen transport layer consists of the data as well as the TCP header. This whole together is called as payload. Next payload. Next, major version indicates the major version of IKE used. So which version 1 or version 2? Major version. Minor version indicates the minor versions in the use. What are the minor versions we are using? Exchange type. So indicates the type of exchange that they are discussed. Okay. So exchange type. Which are the exchange type? We have two types of exchange of key. Internet key exchange. One is manual, another one is automated. So in the automated we have two methods. One is ISEKMP and another one is Oakley. So these are the exchange type that we are using. So this will be told by this exchange type, which is of 8 bits. Flag. It indicates the specific option set for the IKE exchange. 3 bits are defined so far. The initiator bit indicates whether this packet is set by the SA initiator. The version bit indicates whether the transmitter is capable of using higher major version number than one currently indicated. The response bit indicates whether this is a response to a message containing the same message ID. So flag, actually it is of just 3 bits, where first bit will tell you about the initiator bit. It is called as initiator bit. Second bit is the version bit, and third bit is about the response bit. So what is there in the initial bit, version bit and response bit is already present over here. You can read this. Then message ID, as I already told, message ID is nothing but the unique number which is given to the message. So why we will give unique number? Because while transferring the message, some packet may be lost. So that lost packet we can retransmit. If we know the message ID, we can retransmit that lost packet, and we can match our request and response. And this length is nothing but the total length of the packet, total length of the message. This is the total length of the message. So this is about the internet key exchange. Okay. So I request all of you to go through the book and the materials which I have shared to understand all these concepts. Thank you.